Hello, and thank you for watching my Leading with Data Science capstone project. My name is Marcos Lopez, and I'm a graduate summer intern working in the secondary mortgage markets. I was talking with my aunt about a vacation she had taken to Hawaii in 2008. She had told me that while touring the island of Maui, she noticed something strange. During the late evening, on a weekday, she saw people in the streets changing into pajamas and brushing their teeth. Typically, people do these things within the privacy of their own homes. My aunt asked the tour guide what these people were doing, and he told her they were getting ready for bed. Then he pointed to the cars parked in the street and explained that all these people were living in their cars because housing was so unaffordable in the area. Clearly, some relationship exists between vehicles, gasoline, and housing. This anecdote led me to think about the cost of gas and involuntary prepayments. Intuitively, high gas prices reduce overall disposable income and make it more likely for an individual mortgager to default. Given that gas is a relatively inelastic good, when gas prices go up, people still fill up their tanks. Now, they just have less to spend on everything else, including the mortgage payment. Answering this question could have benefits for the entire mortgage industry, both in the primary markets and the secondary markets. If servicers knew the relationship between gas prices and involuntary prepayments, they could better predict which loans and loan areas could become distressed. GSEs, regulators, and servicers could use this information to customize workout plans and foreclosure alternatives that account for gasoline prices. Lastly, by incorporating the cost of gasoline in loan origination, mortgage loan originators could offer better rates that more accurately reflect the borrower's true ability to repay. I just overviewed the purpose of today's exploration. Next, I will go over the dataset and data tools that were used to conduct this analysis. Then we'll look at the data summary statistics. Next, I'll show you what the model has to say about the data. And lastly, we'll summarize what we learned. To conduct my analysis, I used three tools: Snowflake, Excel, Radiant, and Click Auto ML. First, I used the Fannie Mae single-family historical data that Lubomira, Greg, and Alvin provided us with. This data is rich and covers over 20 years of historical Fannie Mae single-family loan level data. Using the engineered involuntary prepayment fields that the team at Polygon Research built, I was able to easily distinguish from voluntary prepayments and involuntary prepayments. I chose to focus on loans that were originated in the past 5 years and focus solely on loans in Hawaii. My PC is a bit of a clunker, and Hawaii was great to work with because it yielded smaller data sets. For the gas price information, I used the National Energy Information Administration's data on average gas prices by month for the past 5 years. Interestingly enough, I tried to get Hawaii's gas prices for the past 5 years, but even though historical data going back to the 90s was available, the data for the past 5 years was unavailable on the EIA website. Initially, I did a SQL query on Snowflake to pull the past 5 years of Hawaii's mortgage data, making sure only to pull unique records. Then I used Excel and VLOOKUP to create a master CSV file that combined the Fannie Mae mortgage data with the EIA gas prices. Next, I used Radiant to summarize and familiarize myself with the data. And lastly, I used Click Auto Machine Learning to run regressions and machine learning on the final dataset. From July 2017, roughly to today, Fannie Mae has purchased and securitized 65,282 mortgage loans from Hawaii. Of this total, almost 500 have undergone an involuntary prepayment. This represents about 0.75% of the total loans originated in Hawaii. Whereas a voluntary prepayment can be a good thing for a borrower, such as refinancing to lock in a better rate, involuntary prepayment is never a good thing. It means that the borrower or the property, or both the borrower and the property, are distressed. This graph plots the mean gas price for all involuntary prepayments in Hawaii by month. We see that involuntary prepayments occur all throughout the time period and at a large range of different gas prices. Leveraging Click Auto ML to predict involuntary prepayments, we use gas prices, origination features, loan terms, and borrower characteristics to produce a model that has 99% fit. This could be a strong indication that we are overfitting our model. To help reduce overfitting, I removed some economic indicators that I felt were too correlated with gas prices, such as unemployment and the 30-year Treasury rate. Despite this, our model still gave a very high fit. Looking at the chart, we can see that gas prices are a strong predictor of involuntary prepayment. Intuitively, this makes sense. Fuel costs can be a significant portion of a family's disposable income, and increasing gas prices reduce a family's ability to pay the mortgage. The following correlations matrix shows us that the rest of our predictors don't have strong correlations with each other, allowing us to be more confident in the robustness of our model. Interestingly, gas prices and involuntary prepayment have a strong negative correlation. Personally, I find this a bit counterintuitive. Here, we see that gas prices were a significant contributor in the overall model, which reaffirms our premise that gas and involuntary prepayment are related. Going back to Radiant, we can see that of the mortgages that did not involuntarily prepay, the gas price on the final payment was $3.41 a gallon, whereas for the mortgages that did involuntarily prepay, the gas price on the final payment was $2.81 a gallon. This is a bit counterintuitive. One would initially think that higher gas prices would be associated with involuntary prepayment, given that higher gas prices have a stronger negative effect on total disposable income. This distribution shows all 498 involuntary prepayments and buckets them by gas price. As we can see, most involuntary prepayments do not occur at the highest gas prices of $3 a gallon or even $3.50 a gallon, but instead, a majority, most of these involuntary prepayments cluster right around the $2.75 a gallon mark. In summary, it is clear that gas and involuntary prepayments in Hawaii have some connection. While our current model is likely an overfit, the results show that the relationship between gasoline prices and involuntary prepayments merits further research. One possible explanation for the negative correlation between gas prices and involuntary prepayments is that when put on the brink of a default, a borrower will often compare the cost of paying the mortgage versus the cost of living elsewhere, whether that be in an apartment, a family member's home, or even their car. If someone is considering living in their car due to zoning ordinances, parking laws, and often the complaints of nearby residents, they may have to move the vehicle frequently. This would cause the distressed mortgager to spend more on gas. It's possible that when gas prices increase, it makes the cost of living in the car more expensive and thus less attractive as an alternative to paying the mortgage. I want to thank you again for listening to my presentation, and I want to take this moment to thank Lubomira, Greg, and Alvin for teaching the Leading with Data Science class. This class has really helped me sharpen my quantitative skills and become familiar with the leading mortgage data science tools. The ability to use fresh data and to develop models to answer my own questions has proven invaluable to my growth as a mortgage professional. Thank you again, Lubomira, Greg, and Alvin, for giving me your time and for sharing your knowledge with me. Thank you.